ASDIP WOOD 3 has been released. It includes great new features and improvements that will be very useful in your practice. But what is included in ASDIP WOOD 3? This is Javier Encinas, and today we're going to review the features and benefits of this new package of ASDIP WOOD 3. Let's get started. The package includes 4 modules for wood column, wood beam, wood bearing wall, and this new module, wood shear wall. In addition, the package can work in different system of units. We can use US units, kips, feet, inches, KSI, SI units, kilonewtons, meters, centimeters, or megapascals, or MKS units, tons, meters, centimeters, or kilograms per centimeter square. I have created a set of examples to illustrate all these modules. Let's start with the new module in ASDIP WOOD 3 for wood shear wall. Double click on the example. And this is the template of shear wall design in ASDIP WOOD. In the geometry tab, we enter all the geometric information, all the sizes, for example, the story heights, wall segments, and the opening sizes. The program accepts up to 5 stories and 5 segments. To select the sheathing and nailing, just click on this button for the database, and the database table 438 shows up. Here you can select the combination of sheathing material, panel thickness, nailing spacing, nail size, and so on. And the database will give you the shear strength corresponding to that combination. In this case, we have selected 516 wood structural panels, sheathing. The nailing is 6D nails at 6 inches spacing, 1¼ bearing length. And the shear strength corresponding to that combination is 1010 PLF. Here we can specify if the sheathing is on 2 sides of the wall or just on 1 side, and if the panels are blocked. Let's go to the studs tab. In all modules in ASDIP WOOD, we can select either sawn lumber, glulam, or composite section. In either case, we can specify the species, and also we can select the sizes from the database. In this case, for example, is the table 1B of NDS. Here we can select the size that we are interested in. If we go to the glulam, same applies, but it's a different table. Now it's different table 1D. Here we can also select the desired size of the studs. In this case, we go to sawn lumber, and the size that we selected is 2x6, corresponds to a southern pine material. We go to the materials tab. Here we can select the material properties in the database. If we click on this button, we are presented with the table 4B from NDS. Here we can select the different species available for this southern pine selection, and then the database will show the corresponding material properties. We go to loads tab. Here we enter the loads for the different load cases: dead, live, roof live, snow, wind, and seismic. The design method can be ASD or LRFD. In this case, we are designing per ASD. If we click on the seismic provisions parameters, here we are presented with the SDS and the redundancy factor rho. All these factors will affect the load combinations in the program. At the right side, the at-a-glance tab shows a summary of the results, the adjusted design values, then the bearing stresses, everything is passing in this case, and then the chord stresses. Here we can see that there's a deficiency here, so we can investigate further. If we go to the condensed tab, this is a more detailed set of calculations grouped by topic. The program calculates the shear strength per story and per segment, and depending on the aspect ratio, the program determines if the segment is valid to resist shear loads. Calculates the unit shear and then the shear strength in wind and in seismic. Then the program calculates the story shear. The ratio is 1.11, so it's 11% over the limit. The program calculates the tension chord analysis per the corresponding controlling load combination. Finally, the program performs the analysis of the compression chord. The program calculates the adjustment factors per NDS, then calculates the adjusted design values, and finally checks the chord stresses. Finally, the bearing stresses are checked here. If we go to the detail tab, this is a more detailed set of calculations, step by step, stud section properties, the reference design values, and then the calculation of the shear strength, the storage shear calculation for the controlling load combination, the compression core analysis, finally the core stresses, finally the bearing calculations. The program generates the interaction diagram in compression and in tension. Finally, in the construction tab, we can see a shear wall elevation. Let's go back to the project manager. Let's open a calculation for a wood column. Similar to the previous module, we can specify either sawn lumber, glue lamp, or composite sections. The materials tab, similar to the previous module, we can specify the material properties from the database. Here we can specify if the loads are pre-combined or if it's a set of nominal cases and let us decombine them. And we can specify an axial load P, horizontal uniform load, and a concentrated load at the midspan. In the right-hand side, in the at-a-glance tab, we can see a summary of the results. Here immediately we can see that there are some deficiencies here that we can investigate further. If we go to the condensed tab, some more detailed set of calculations grouped by topic, the adjustment factors and the adjustment design values, then the combined stresses for this column. If we go to the detail tab, a more detailed set of calculations step by step, the adjusted design values, the calculation of the combined stresses, finally the bearing calculations here. Graphically, the program generates the interaction diagram in tension and in compression for this column. Let's go back to the project manager. Now let's open a calculation for a wood beam. And this is the template for a wood beam. In this example is a glue lamp, and we are specifying a single span wood beam, 32 feet long span. Graphically, we can see the beam here in the loads tab. In this example, we are not applying a uniform load, just a cell weight, but we have some concentrated loads. The program generates the corresponding shear diagram and the moment diagram. Let's go to our glance tab. Here the program shows the bending results and then the shear results. Let's go to the condensed tab. Here we can see the support reactions, shear forces, then the bending moments and the bending strength, the shear strength. Let's go to the detail tab, the reference design values, then the adjustment factors with the references to the NDS code. Here the bending calculations for the beam, shear calculations, bearing calculations. Let's go back to the project manager. Let's open a calculation for a bearing wall. And this is a template for a bearing wall design in ASDIP WOOD 3. In this case, a glue laminated Western species. We have selected the size from the database, 2x6. In the loads tab, we have specified vertical uniform loads or concentrated loads at certain spacing. In addition, in wind, we can specify a wind pressure here. This is a typical case for an exterior wall in a wood building. In the right-hand side, in the at-a-glance tab, and then the calculated combined stresses in tension, compression, bending, and shear. Finally, the bearing stresses. We go to the condensed tab, adjustment factors, adjusted design values, and then the calculated design combined stresses. In the detail tab, we can see a more detailed set of calculations step by step, then the calculation of the combined stresses. Finally, the calculation of the bearing stresses. Graphically, the program generates the interaction diagram. All the loads are inside the usable area, so graphically we can see that the design is acceptable. As you can see, this new package, ASDIP WOOD 3, is very useful in your design practice. We were able to design, check, and optimize different examples in just a few minutes that otherwise would take probably hours if we do it by hand. If you like the software, please visit the website www.asdipsoft.com and download the free 15-day trial. Please subscribe to the channel if you want to receive notifications in the future for similar videos. Thank you for your attention.